Hi, welcome to my channel Network Simple, and today we're gonna be talking about STP. So let's go. I'm gonna be breaking down very efficiently, and I hope it's very effective. That means it's simple to understand. So what is an STP itself? So STP is spanning tree protocol. It just means creating a path between the switches. So there are gonna be multiple switches in your network, and how it's gonna know from from the laptop to the main switch. How can it reach to the main switch? How can your laptop reach to the main switch? And this is what it goes between in the switches side, which is understanding their path, which is how they are called. Hey, this is the switch you need to go, you need to reach to the main switch. So the first thing we see is lowest path cost. Now, what is the lowest path cost? Lowest path costs are Ethernet cables, optical fibers. So, so they have a set cost which is 19 for the path cost yani it's more preferred the lowest high path, which is you can see the fibers has the lowest. So first it checks the lowest path cost. Then second, it moves to the priority. Now the default priority, now the default priority is 32,766, 768, and the lowest it can go is the 4096. So basically, low again it becomes the to make root bridge, which is to make it a main switch. This is the election process. Now, since in here in this diagram, this is a diagram about understanding what is a designated port and root port. So a switch can have a switch cannot have two root ports. It can only have the designated port and the root port, but the switch cannot have two root ports. Now, when the switch is the main, okay, it it will create a status to the link. Hey, my switch is I'm the main switch, so I will be called designated port, and this whole area is will be called root bridge, which is anything leading uh, from the slave to the main switch. Anything to the other switches that gonna connect to the main switch are gonna called root port, and this process is called root bridge, since a main switch root bridge. Okay, root now the switch cannot have two root ports. So in this diagram it got elected. Okay, high lowest, since the MAC address is the lowest, the switch 2 also is the lowest, and then the same process in the switch 3, and then the switch 2 and the switch 3 are arguing, hey, which is the lowest. I'm the lowest, which is, and now it will create a designated port because it's gonna lead to the root, the main one. So designated port, it also means that I'm better than you. And then since the switch cannot have two ports, it's gonna block it. It will go to the block port or the root port, and in here it already has the root port, so it will block this port. And this is how, if priority are equal, go to the, this is the process. Lowest MAC address win, which is lowest MAC address. Then lowest port priority, port, I don't know what that is. And then is the final lowest port number. Okay, portner G00. And yeah, this is called STP. Okay, now we're gonna be understanding how to understand the STP information. So this is the command show spanning tree VLAN 1, and The main thing in here they say is the P2P and P2P edge. So what do they mean? P2P is the full, it's not about who is connected. So full duplex between zero switch to pair full. So full duplex, it means you can receive and send at the same time. You don't have to wait. So duplex, it's that. Then P2P export. What is port for? Skip STP, listening and learning state. So STP goes to block disabled, blocking, listening, learning. So it directly goes to the forwarding stage in here. So when do we use the port fast? PC, we use it that does not create like PC laptop. So this is what it means by P2P and P2P edge. And one line memory, this is what it means. So now there are scenarios where a switch falls down, it fails out. So these are the phases in this slide. It talks about phase one, switch one detects a link failure. Now what I turned it into a chat GPT session. Direct link goes down when this happens. People must recalculate. Revert the recalculation. Cable goes down. The switch sees the link is dead. Mm-hmm. Okay. Detects links down. Flashes MAC address. Chooses a new route port. Okay. And then there's a second scenario that happened, which is this one. STP topology changes. The switch that detects a sensor topology change notification, cable, example, the shape of the network change, creates a new and it then flooded all 12 switch. STP if so what I wanna know also, so it needs to see a backup path for that. Fine to reach the root indirect. It needs more time to recall the path needs a new route must route be a new route. That means the main switch is fall down. We vote for a new leader regular length on one part, not the route. And yeah, this is the verification for to see the spanning tree detail if there's any changes happens and all. The MAC table is a list that gives devices. PC one is this has the switch for which devices. Why does the part to do so the switch maximum also it can be link change which nice link changes. PC one is now reachable from port 7. Learns the new so This is the phase 1, phase 2. So it does what Edward does. I don't know why they talk in so long. Converging with direct linear general. Okay. But all it's the, all I know it's just all it does is just uh restarts. And yeah, that's all. Not the whole changes form, maybe it becomes flash the mic. It updates the pattern for our so usage can when does it stay re-elect? Okay. Direct, indirect, or any direct or that's all. Let's go with the RSTP now. So what's the difference between RSTP and the STP? So RSTP is just a more better version of the STP process. What it does is that it it removes the blocking and listening stages and goes to disabled learning and forwarding. What it mentioned in here, RSTP has discarding learning only 3 states instead of 5s. uh, and what it does of the blocking, it turns that into a backup path. It doesn't wait, it already gives a backup port ready. I want to know how does it create backup. So this is the difference of RSTP and STP. If the link failed, the switch wait and we compare. This is why STP is slow. It does not care. It looks at all possible routes, choose the best, makes the next. Mm, cost for root port, alternate port, CDB, CDB, CB root, CB root, root port equal alternate second best, capture but not forwarding. What happens when the main alternate immediately? No waiting, no nothing. Nice. That's all.